Okay, so today we're going to talk about gas stoichiometry. So that is back and it is not going away. So the diagram that I kind of want you to think about is the stoichiometry diagram that we've looked at before. I'm kind of show you the whole thing at once. So remember, this is where you can go from like grams of one substance to grams of another, but you have to stop at moles and use the mole ratio in between. So we're going to be using that same idea, except we're going to be going to liters this time. And so the nice thing about liters is that liters is always the same number. It's always 22.4 liters equal to 1 mole. So we can actually go from grams to moles to liters of something else, or from liters to moles to molecules or something like that. So it's just going to be another box in our stoichiometry method, okay? But we're going to be focusing on kind of all different ways. I'm going to show you how to do it with liters, grams, and molecules. So you will need a graphing calculator that has the times 10 capabilities. Okay, so these are the 3 examples that I'm going to do, and you'll probably want a periodic table and a calculator handy, so that way you can get the answers with me. So let me grab some pens. All right, so it says, how many liters of chlorine gas are in 2.63 moles of oxygen gas? Okay, so liters of chlorine gas are in 2.63 moles of oxygen. So just like before, we're going to start with our given, 2.63 moles. And then if we look at our balanced equation, the one that's just oxygen is this one, so that's O2. Notice it's just the symbol, not the number in front. We're going to use that in the mole ratio in just a second. All right, so just like before, nothing goes here. If this is moles of O2, then down here has to go moles of O2 so we can cancel it. And this is the first time I have moles on bottom, so I'm going to circle it. That's going to be my mole ratio. And I'm going to go to moles of the new thing on top. Now I'm asking for liters of chlorine gas. So chlorine is Cl2. So that's what I'm going to go to first. I'm trying to get all the way to liters, so I'm going to draw another line. And then this is moles of Cl2, so down here has to be moles of Cl2 so I can cancel it. And then I can go to liters of Cl2. So let me show you on the little diagram kind of what we did. So we started with moles of substance A, then we made it cancel and we used our mole ratio and went to moles of substance B, that's our chlorine. Then we went to liters of substance B. The reason why the chlorine here and chlorine here matched is just so we can cancel it, same thing here. All right, so outside of the circle, the number that goes with mole is always a 1, so that part is still true. Liters always gets 22.4 unless it's part of the given, okay? So liters is always going to be 22.4 liters in a mole. And then our mole ratio, we're going to use our balanced equation. So the number in front of O2 is 7. The number in front of Cl2 is 2. Remember, we only use that balanced equation, the numbers in front inside the mole ratio inside the circle. All right, so let's look at things that cancel. Grab a different color here. So we have moles of O2 that cancel, moles of O2, moles of Cl2, and moles of Cl2. To solve, we're going to multiply the tops and divide every time there's a number on the bottom, okay? So 2.63 times 2 times 22.4 divided by 7 divided by 1. All right, so we get 16.832. You can see that right there in my calculator. So let's talk about sig figs. Our first box tells me how many. That one has 3 sig figs. So this is going to be 16.8 liters Cl2. The reason why it's 16.8, the 3 makes the 8 stay the same. And then I add my unit that didn't cancel, liters Cl2. All right, so let's try another one. How many liters of NO2 are in 14.9 grams of nitrogen gas? So I'm going to start with my given, 14.9 grams. All right, now it says nitrogen gas. So the one that's just nitrogen is going to be N2. I'll go ahead and draw my line. Nothing goes in this box. So let's look at our diagram and see where we're going. I'm starting with grams of substance A, and I'm asking about liters of substance B. So I'm going from grams of A to liters of substance B. So from grams, the only place I can go is moles. Then I'm going to use my mole ratio. Then I'm going to go to liters of substance B. So we're kind of doing this weird little shape here. All right, but it's going to need 4 boxes. This is a box, this is a box, this is a box, and this is a box. Okay, so if this is grams of N2, down here needs to be grams of N2 so I can cancel it. Then we just said from grams, the only place we can go is moles of the same substance. So moles of N2. We have not changed substances. The only time you can change compounds is in that mole ratio. Draw my line because I'm not there yet. I'm trying to get all the way to liters of something new. Right now I have moles of N2 on top. So moles of N2 goes on the bottom. This is the first time I have moles on the bottom, so I'm going to circle it. That's my mole ratio. All right, so on top, I'm also going to go to moles, but this is going to be moles of the new thing. The new thing I'm asking about is NO2, so that's what I'm going to go to on top. All right now I have moles of NO2. This is going to be moles of NO2. Now, am I going to circle this one? No, because it's not the first time I have moles on bottom. Okay, only the first time you have moles on bottom is your mole ratio. Then I'm going to go to liters of NO2. So to recap again, what we did is we went from grams of substance A to moles of substance A. That's right there. Then we went to the mole ratio. That's this. Then we went to liters of substance B. Okay, so that's kind of how we did that. All right, so outside of the circle, the number that goes with mole is a 1. Inside the circle, we're going to look at our balanced equation. In front of N2 is a 1. In front of NO2 is a 2. All right, liters is always 22.4. So that number goes there. Unless it's the given, it's going to be 22.4 liters in a mole. Okay, and then grams is going to come from the periodic table. So we're going to look up the mass of N. We haven't done that in a while. So that's 14.007, but the formula is N2. So I'm going to take that 14.007 and multiply it by 2. And that is 28.014. A little bit of molar mass review there. All right, let's look at things that cancel. Grams on top, grams on bottom, those cancel. Moles of N2, moles of N2, moles of NO2, moles of NO2, and I'm left with liters of NO2, which is what I'm asking for. To solve, remind you of that. We're going to multiply the tops, divide every time there's a number on the bottom, okay? So I'm going to type that in so you can see. So, let me clear that. 14.9, 14.9 times 1 times 2 times 22.4 divided by 28.014 divided by 1 divided by 1. Okay, so sig figs, our first box here has 3 again. So this is going to be 3, so it's going to be 23.8. This 2 makes the 8 stay the same. And the unit that didn't cancel is liters NO2. Okay, so that's how you do number 2. All right, last example. This is where you're going to for sure need a graphing calculator because we're going to use that 6.02 number with the times 10. All right, how many molecules of hydrogen gas are in 39 liters of HF? All right, so I'm going to start with my given, 39 liters HF. All right, so let's see on our diagram where we're going. We're trying to get to molecules and we're starting with liters. So we're starting with liters of substance A and we're trying to get to molecules of substance B. Let me turn it a little bit sideways so you can see it. All right, liters of substance A, we're trying to get to molecules of substance B. So from liters, the only place we can go is to moles. Then we're going to use our mole ratio, which puts us in the new compound. Then we can go to molecules. So it will still need 4 boxes. 1, 2, 3, 4. Okay? So nothing goes here. If this is liters of HF has to go down here, has to match so we can cancel it. We just said from liters, the only place we can go is moles of the same substance. So we're going to go to moles of HF. All right, draw my line. Right now on top I have moles of HF. Down here is going to be moles of HF so I can cancel it. It's got to match. Okay, this is the first time I have moles on bottom, so it's my mole ratio. I'm going to circle it. That means I'm going to have moles on top. This is going to be moles of the new thing. The new thing is hydrogen gas. So hydrogen gas is going to be H2. All right, we got to go one more so we can get to molecules. So we have moles of H2. So down here has to be moles of H2. Again, I'm not going to circle it because it's not the first time I have moles on bottom. Only the first time is at the mole ratio. And then on top, I'm going to go to molecules of H2. All right, so outside of the circle, mole gets a 1. Inside the circle, we're going to use our balanced equation. So in front of HF is a 2, and in front of H2 is a 1. All right, liters is the new number we're talking about today. Is always 22.4 liters in a mole. So 22.4. And then our molecules is always also the same. It's going to be 6.02 times 10 to the 23rd. Okay, let's look at what cancels. So we have liters of HF cancel because one's on top and one's on bottom. Moles of HF cancel because one's on top and one's on bottom. Moles of H2 cancel, and we're left with molecules of H2, which is exactly what we're looking for. So to solve, you're going to multiply every number on the top and divide every time you have a number on the bottom. Okay, so I'm going to use my calculator to show you how to do that again. Scoot this up a little bit. So we're going to do 39 times 1 times 1 times 6.02. Second comma, remember that, 23. We're not using a times. That is not a multiplication problem. Only the things I wrote in green are times. Okay, and then we're coming to the bottom now. Divide 22.4, divide 2, divide 1. Okay, notice our answer has an E. That means times 10. That's good because molecules are teeny tiny, so there's going to be a lot of them. So sig fig wise, our first box here had 2 this time, so this is going to be 5.2. The 4 makes the 2 stay the same. So 5.2, the E means times 10, and then this is our exponent, 23. And then our unit is molecules H2. Okay, so I told you stoichiometry was not going away. Just now we're doing this with liters. Now this only works for gases, which is why it's in the gas law unit. 22.4 liters of a gas is equal to 1 mole of that same gas, okay? So all of these will be for a gas, and you're gonna have to show your work just like we did in the past. I'm gonna post a picture of this diagram on Canvas for you to look at if you need it, okay?